Okay, good day everyone. For today's video, ang ating topic is regarding sa ating pressure. Ito yung ating hydrostatic pressure sa ating fluid. So again, introductory lang tayo with regards sa ating topic. Further discussion is when mag-move up na kayo sa higher subject, which is yung ating fluid mechanics and hydraulics. Okay. Under sa ating pressure is ang ating Pascal's law. Yung ating Pascal's law is developed by a French mathematician named Blaise Pascal. Itong Pascal's law, it states that the pressure of a fluid is equal in all direction and in all parts of the container used. So imagine natin, meron tayong container dito with different, nakakonect dito yung mga different shapes which is represented dito, ito na part na ito. Okay? So meron tayong bigger container kung saan nakadikit yung mga different shapes na container. Okay, so imagine natin meron papasok na liquid dito sa ating inlet. So papasok yung ating fluid or liquid. So papasok siya to same din sa mga different shapes ng ang container na nakakonect. And then with the pressure, magsa-stop yung ating liquid level with the same level with regardless sa shape and angle ng mga connected na container. Okay? So yung pressure natin or unit pressure is represented as big letter P. So it is a physical force exerted on an object. It is also the force applied perpendicular to the surface of an object per unit area. So perpendicular ha. So meron tayo ditong representation. So yung ating force P or pressure nag-act doon sa ating area. So ang formula natin para sa ang equation natin para sa pressure is equals to force over area or F over A. And then meron din tayong types of pressure. So sa types of pressure, meron tayong atmospheric pressure at above sea level na ito ha or at sea level. And then yung pressure difference ng gauge pressure, which is, ulit natin na, yung atmospheric pressure is at sea level. And then yung gauge pressure natin is yung pressure above the atmospheric pressure or above the atmosphere. So below is the vacuum pressure, which is the pressure below the below the atmosphere. And then, meron tayo dito absolute zero. And then yung absolute zero is at the bottom ng ating vacuum pressure. And then yung absolute pressure naman is the difference between doon sa gauge pressure and then sa above the zero or above the absolute zero. Yung ating absolute pressure. Okay, so meron din tayong differential pressure between 2 points within sa gauge pressure. So difference in pressure between two given points. Okay, so i-define natin yung definition ng mga types of pressure. So first, we have here atmospheric pressure. It is also called as barometric pressure. It is defined as the force per unit exerted against a surface by the weight of the air above that surface. Yung pressure natin at sea level is approximately 1 atm. Yung atm na yan is atmosphere. Yan siya, atmospheric pressure. So, again, at pressure natin at sea level is approximately 1 atm. Yung 1 atm, meron siya iba't ibang unit. So, ipag-discuss natin dito. Meron tayo ditong 760 mmHg or millimeter mercury, 14.7 psi, 101 kPa or 101 kPa. And then lastly, meron tayong value niya na 1.013 bar or barometric pressure. So magde-differ lang ito, depende dun sa unit, magdedepende kung anong gagamitin mo dito. Depende sa unit na gamit doon sa ating problem. So kung naka-PSI, yung ating unit sa problem, itong PSI ating gagamitin, 14.7. Kung kPa, itong 101. So nandito lang sa dalawa yung parating ginagamit. Okay. So next is yung ating gauge pressure. It is the pressure relative to the atmospheric pressure. It is used to measure the pressure difference between a system and the surrounding atmospheric pressure. Therefore, when exposed to atmosphere, the gauge pressure is 0. So tandaan ninyo, ito siya ha. Itong statement na ito. Once na open or exposed yung ating liquid pressure, yung ating liquid surface, ang gauge pressure natin is equals to 0. So next is yung ating vacuum pressure. It is the pressure below the atmospheric pressure. It is also known as the negative gauge pressure. A perfect pressure is never possible in practice. It is not observed then anywhere in the universe. Next is absolute pressure. It is the pressure above the absolute zero. Absolute pressure is equals to the atmospheric pressure plus gauge pressure. So tandaan ninyo din itong statement na ito. Ang ating absolute pressure is equal to the atmospheric pressure plus gauge pressure. So itong atmospheric pressure, balikan natin. Ay, wag na. So example, kPa. So 101 kPa plus yung gauge pressure. Itong gauge pressure na ito, binibigay sa problem or minsan hinahanap. So itong atmospheric pressure, hindi siya binibigay sa ating problem. Pero once na sinabi na find the absolute pressure, ibig sabihin nun, ipa-plus mo pa yung atmospheric pressure doon sa gauge pressure. So tandaan nyo, tricky ang mga problem. So make sure na knowledgeable kayo or natandaan nyo itong mga conditions na ito. And then last, yung differential pressure. It is the difference in pressure between 2 points. Differential pressure is equals to pressure 0.1, example lang, minus dun sa pressure sa 0.2. Again, ang minus or yung pressure difference is from higher pressure minus doon sa lower pressure. So next is yung ating variation in pressure. So imagine niyo, introduce lang natin kung paano na derive yung ating formula under or with regard sa variation of pressure. So let's start. Imagine niyo itong line na ito, color blue na ito is ang ating surface surface level. Oh, no. Surface. Nalilito ko. Level ng ating surface. Liquid surface pala. Tutuyo ang ulo ko. Okay? Ito ang ating liquid surface. Itong line na to. Okay? So imagine natin, meron tayong object na nakasubmerge. Okay? With length A and then thickness or area na A, small letter A. Okay? And then meron tayong point 1. Yung point 1 natin is nasa low pressure. So nasa top yan siya ha. And then yung point 2 natin is higher pressure which is nasa bottom. Kasi deeper yung ating point, the deeper sa water, mas higher ang pressure. Okay. So sa point 1, nag-aak ang ating force sub 1 and pressure sub 1. And same goes sa ating point 2. Doon nag-aak ang ating force sub 2 and pressure sub 2. And then with this object, meron din tayong force na nag-aak, which is yung weight ng ating object. And then, since ang ating sample na submerged object is naka-incline, so meron tayong i-consider na angle of inclination. And then, kukunin natin yung height, vertical height nung ating from point 2 to point 1. So with that, meron tayong H na equals to L sine theta. So, trigon, ano na ito ha? Trigon na ito, na topic na ito. Paano naging ganyan yan value niya? Is example, illustrate na natin. Ito yung L natin, yung length. Okay, so parang triangle lang. So, mayroon tayong angle. And then yung H natin, yung height from point 1 to point 2, vertical height. Okay? So, with that, yung H natin is equals to L sine theta. Kaya siya naging ganyan. Okay? Okay, next. So, yung weight natin, another formula is gamma times volume. And then yung volume natin is ang formula niya is area times length, okay? So with that, magsa-summation tayo ng forces. So meron tayong force sub 2 minus force sub 1 equals to weight sine theta. So yung ating pressure, di ba? Ang kanyang formula is F over A. So kung kukunin lang natin force, nangyayari niyan magiging pressure times area. Okay. So kaya naging ganito siya. And then yung area natin, same naman, di ba? Kay yung object natin ang gina-consider. So ang area niya represented as small letter A. So doon na lang tayo magbabari doon sa pressure. Kaya meron tayong P sub 2 area minus P sub 1 area. So ito yung representation niya or kanyang formula. So equals to yung W natin, balik tayo dito. Okay? So ito substitute natin dito. Kaya siya naging gamma times area times length sine theta. So with that, maka-cancel out lang natin yung ating area. So cancel ito, cancel ito, cancel ito. Mangyayari, ito na siya. So P sub 2 minus P sub 1 equals to gamma H. Okay. So yung variation in pressure represented in this equation, ito ang ating formula. So tatandaan niyo lang. Next, if yung ating point 1 lies on the free liquid surface, okay, so ibig sabihin nun, yung ating point nasa free liquid surface, then yung ating point pressure at that point is 0. So mangyayari yan, yung P sub 1 natin is 0, so isi-0 na yan siya, so mangyayari P sub 2 is equals to gamma times height. Or hindi na tayo maglalagay ng P sub 2 kasi 0 naman yung P sub 1. So, paano ba ito? Yung mga terms nakakalimutan ko. So, obviously, ang ating formula is P is equals to gamma H. Okay? Okay, tagal. So, meron tayo dito, sample problem na tayo. If, excuse me, if depth of liquid of 1 meter causes pressure of 7 kPa, what is the specific gravity of liquid? So, solution, yung formula natin is P equals to gamma H. So, yung meron na tayong pressure, diba? Which is 7 kPa. Yung gamma natin is specific gravity. Okay. Specific gravity, which is denoted natin dito as S. Ito siya. Okay? So, pressure equals to 9.81 times specific gravity times yung height na 1 meter. Yung ating gamma kasi, ang formula niyan is yung ating 9.81, which is constant talaga yan siya. Diba? Times natin yan siya sa specific gravity. SPGR. So, specific gravity. Okay? So, kaya siya naging ganyan. So, 9.81 times S, which is yung representation ng specific gravity, times noon sa ating height. So, specific gravity man ang hinahanap. So, isa lang yung ating unknown variable. Shift solve lang sa calculator. So, ang value ng ating specific gravity is 0.714. And then again, yung ating specific gravity is dimensionless. So, wala siyang unit. So, ito lang. Ito lang ang inyong ito lang ang answer. Okay. Number 2, what is the pressure 12.5 meter below the ocean? So, gagamit tayo na specific gravity na 1.03 for salt water. So, hinahanap yung pressure. So, diretso lang tayo. So, 9.81 times specific gravity na 1.03 times sa height na 12.5. So, check natin. Okay, hindi na makita. So, yan siya. So, meron tayong pressure na value 126.3 kPa. So, number 3, if the pressure 23 meters below the liquid is 338.445 kPa, determine its unit weight, mass density, and specific gravity. So, letter A, unit weight niya, which is yung gamma, ang formula na gagamitin is yung pressure, di ba? May pressure kasi tayo, so yung pressure na formula. So, pressure equals to unit weight times height. So, meron na tayong value ng kanyang pressure, which is 338.445 kPa. And then, hinahanap ang ating unit weight. So, siyang unknown variable. And then, meron na tayong height. So, meron na tayong equation, which is meron isang unknown variable. Input sa calculator, shift solve. Ang ating unit weight is 14.715 kilonewton per cubic meter. So, letter B or yung ating another requirement, which is yung mass density. Ano ang ating mass density? So, ating mass density, ang another formula, di ba, is equals ganito. Unit weight times rho times gravity. Okay? So, given naman, may value naman tayo sa unit weight, paslak dara, ang ating ginapangita, rho, and then yung gravity natin is constant ang number, 9.81. So, meron tayong rho or mass density na 1,500 kilogram per cubic meter. Okay? And then last, yung ating specific gravity. So yung specific gravity natin, ang formula is S is yung rho ng ating liquid over rho ng ating water. Itong rho ng water na ito, constant yung number na yan. So magdedepende yan siya kung ano yung ating ginamit na mga, ano yung ating mga unit. So yung ating rho ng liquid, which is ito, mass density natin na 1,500 kg per cubic meter. And then yung rho ng water is 1,000. So balikan niyo lang sa video ka na topic natin ito. Yung rho ng water with reference sa 4 degree Celsius. Okay? So meron tayong 1,500 over 1,000. So yung ating specific gravity is equals to 1.5. Okay. So dyan nagtatapos yung ating illustration. So meron na tayong assignment for this topic. So babasahin ko yung inyong assignment. Assignment number 2, problem number 1. What is the pressure? 12.5 meter below the ocean. Use specific gravity na 1.03 for salt water. So wait lang, na topic ata ito. Okay. So again, baguhin natin ito. So 15 meters na yan siya. Okay. So what is the pressure? 15 meters below the ocean. Use specific gravity na 1.03 for salt water. Hindi ko na-edit itong problem na ito ba? Okay, number 2, problem number 2. If the pressure is 25 meters below a liquid is 450 kPa, determine its unit weight, mass density, at saka yung specific gravity. And then last, problem number 3, if the pressure at a point in the ocean is 60 kPa, what is the pressure 27 meters below this point? Number 4, if the pressure in the airspace above an oil with specific gravity na 0.75, surface in a closed tank is 115 kPa absolute, what is the gauge pressure 2 meters below the surface? Okay, so dyan nagtatapos ang ating assignment number 2. Before tayo mag-proceed sa ating last topic for the introduction sa ating fluid mechanics or properties of fluid, mag-play muna tayo ng video for further illustration or para mas ma-visualize ninyo itong ating topic. So sandali lamang. Okay, let's play the video.
In this lesson, we're going to talk about pressure. Pressure is force divided by area. In physics, the standard unit of pressure is pascals. 1 pascal is 1 Newton per square meter. And 1 kilopascal.
Okay, sandali lang. Na-interchange ko ang video presentation. Sandali lamang. So dito muna tayo. Play na natin.
In this video, we are going to see about pressure basics and types of pressure. What is pressure? Pressure is the physical force exerted on an object. Consider an object on which a force is acting perpendicular to the surface. Pressure is the force applied perpendicular to the surface of an object per unit area. area is A, force is F, and pressure is P. Pressure is equal to force divided by area. Types of pressure. There are different types of pressure. We will see 5 important types of pressure here. Atmospheric pressure at sea level. Gauge pressure is the pressure above atmosphere. Vacuum pressure is the pressure below atmosphere. Absolute zero, where there is no pressure exist. Absolute pressure is the pressure above absolute zero. Differential pressure is the difference in pressure between two given points. Atmospheric pressure is also called as barometric pressure. Atmospheric pressure is defined as the force per unit area exerted against a surface by the weight of the air above that surface. Pressure at sea level is approximately 1 atm. Pressure has many units. Here is the equivalent pressure in different units. Gauge pressure is the pressure relative to atmosphere. Gauge pressure is used to measure the pressure difference between a system and the surrounding atmosphere. That's why the reading of pressure gauge is showing 0 at atmosphere. Sometimes, the pressure unit is added with G at the end to indicate gauge pressure. However, without G, it is understood as gauge pressure. Pressure below the atmospheric pressure is called as vacuum pressure. Vacuum pressure is also known as negative gauge pressure. Vacuum pressure is usually indicated with negative sign. Perfect vacuum is never possible in practice. It is not observed anywhere in the universe. Even the space will have a very low pressure, which means not completely vacuum. Pressure above absolute zero is called as absolute pressure. You can notice the word absolute is present in the dial of pressure gauge. Absolute pressure is equal to atmospheric pressure plus gauge pressure. Absolute pressure is always indicated with A at the end of pressure unit. Differential pressure is the difference in pressure between 2 points. Differential pressure is equal to pressure at point 1 minus pressure at point 2. Differential pressure gauge will be connected with high pressure side at one end and low pressure side at another end. The difference between high pressure side and low pressure side will be indicated in gauge.
Thank you for watching this video. For more videos like this, please subscribe to Simple Science.
So, okay, here, proceed tayo sa next video. Play na natin.
In this lesson, we're going to talk about pressure. Pressure is force divided by area. In physics, the standard unit of pressure is pascals. 1 pascal is 1 Newton per square meter. And 1 kilopascal is 1,000 pascals. And 1 atm, or atmospheric pressure, is 101.3 kilopascals. So those are some units that you want to keep in mind. So whenever you exert a force over a given area, that force exerts a pressure throughout that area. So pressure is simply force over area. Now what happens if you increase the area but use the same force? Let's say if we doubled the dimensions. Now if you apply the same force over, let's say, a larger area, the pressure is going to be a lot less. Let's say if we apply a force of 100 newtons. The pressure in this example is 100 divided by 1 square meter, so it's 100 pascals. In the second example, the area is 2 times 2, which is 4. So the pressure is now a force of 100 newtons divided by an area of 4 square meters, so it's 25 pascals. So what you need to understand is that if you increase the force applied, the pressure increases. If you increase the area in which that force is applied, the pressure decreases. The pressure is directly related to the force, but inversely related to the area upon which that force is applied. Let's try this problem. A 15 kilogram rectangular block with a length of 70 centimeters and a width of 40 centimeters rests on the table. What pressure does the book exert on the table? So let's say this is the book. And it's on a table. Now that book is going to exert a weight force on the table. And that force is applied over the area of the book, the bottom area. Now we have a length that's 70 centimeters and a width of 40 centimeters. And we know that pressure is force divided by area. And the force that the book exerts is basically the weight force of the book, which is mg. So the pressure exerted by the book is just mg divided by the area of the book. So the mass of the book is 15 kilograms. The gravitational acceleration is 9.8. And the area, let's get it in square meters. So to convert centimeters to meters, divide by 100. 70 centimeters is 0.7 meters, and 40 centimeters is 0.4 meters. So 15 times 9.8. So that's going to give us a force of 147 newtons. And 0.7 times 0.4, that's going to give us an area of 0.28 square meters. So if we divide these two numbers, the pressure exerted by this book alone is 525 pascals. So this is the answer. Number 2. A closed rectangular container with dimensions 4 meters by 5 meters by 6 meters is filled with water. What is the pressure exerted by the water on the bottom face of the container? So let's draw a rectangular container. And it's filled with water.
Oh, dami nito.
Oh, is the pressure that's exerted by the weight of the water on the bottom surface of the cube. So how can we do that? Well, we know pressure is force over area. And keep in mind, the density of water, if you're wondering, is 1,000 kilograms per cubic meter. Now, the force is the weight of the water, which is mg. And we don't have the mass of the water. However, we know that density, which is rho, is mass over volume. Don't confuse this with pressure. So the mass of the fluid, if we multiply both sides by V, is density times volume. So the pressure of the fluid is going to be the mass, which is density times volume, and then times gravitational acceleration, divided by the area. Now, the volume of, let's say, this rectangular prism is the length times the width times the height. So let me write that somewhere. Now, the length times the width will give us the area of the bottom surface. Or rather, I'm just going to replace volume with length times width times height. And the area of the bottom surface is just the length times the width. So we could cancel L and W. So the pressure that's due to the weight of the water alone is going to be the density of the fluid times the gravitational acceleration times the height of the fluid. So here it is. This is the equation that you want to keep in mind when dealing with the pressure due to a fluid. So we know the density of water is 1,000 kilograms per cubic meter. We have the gravitational acceleration, it's 9.8, and the height of the fluid. Now let's say the first one is the length, the second is the width. So the height, we're going to say it's 6 meters in this example. So it's going to be 1,000 times 9.8 times 6. So the pressure is 58,800 pascals. So that's the pressure due to the weight of the water alone. Number 3, A closed cylindrical container is filled with a fluid that has a specific gravity of 1.7. What is the pressure exerted by this fluid at a depth of 15 meters? So let's say this is the cylindrical container, and it's closed, and it's filled with some fluid. So at a depth of 15 feet, not feet, but 15 meters, let's say at this point, we want to know what's the pressure exerted at that depth. So we can use this equation. The pressure is equal to the density times gravity times the height. So if you have a fluid and you want to find the pressure exerted by the fluid alone at a certain depth, this is the equation that you can use. Now we need to know what the density of this fluid is, and we're given the specific gravity. The specific gravity is the density of the substance, in this case the density of the fluid, relative to the density of water. So the density of the fluid is going to be the specific gravity times the density of water. So we have a specific gravity of 1.7, and the density of water is 1,000 kilograms per cubic meter. So the density of the fluid is 1,700 kilograms per cubic meter. Now we have the gravitational acceleration, and the depth is 15 meters. So it's 1,700 times 9.8 times 15. So the pressure exerted by this fluid at a point where it's 15 meters deep is 249,900 pascals. And if you divide that by 1,000, you could say it's about 249.9 kilopascals.
So, dyan nagtatapos yung presentation doon sa ating pressure. So, next topic is yung ating buoyancy. So, again, yung topic natin, buoyancy. So, here, define na natin before tayo mag-tackle doon sa ating buoyancy. So, here we have a liquid volume. It is when the metric system was created, they decided that 1 cm cube of water is equal siya sa 1 millimeter of water. And the 1 ml of water will have a mass of 1 gram. So tandaan nyo itong statement na ito. So again, yung 1 cm cube of water equals siya sa 1 milliliter of water. And then kung sa kilogram naman or yung mass niya is 1 gram. So water displacement, we can use water displacement to find the volume of objects that are not boxed shape. We can put water in graduated cylinder. Example nito ha. If a rock causes the level to rise from 7 to 9 ml, then the rock must have a volume of 2 ml. Okay, next is density. Yung density is the amount of matter or mass compared to the amount of space or yung ating volume to the object occupies. We will measure mass in grams and volume in ml or cubic centimeter. Density is a mass divided by volume, or density equals to mass over volume. And then under dito sa ating buoyancy is yung ating Archimedes Principle. In the 3rd century BC, a Greek mathematician named Archimedes realized that buoyant force is equal sa ating weight, or equal siya sa weight of fluid displaced by an object. Example nito is ito ating nasa figure, this part. So, sample experiment can be done to measure the buoyant force on a rock with a spring scale when it is immersed in the water. So, ito yung ating initial setup. So, yung ating in air, yung mass ng ating block is 7 pounds. So, nung disubmerged na siya, by Archimedes Principle, yung ating buoyant force is equal siya doon sa weight of the displaced water. So, pag submerge natin doon sa block, yung kanyang weight is bumaba from 7 pound naging 4 pound. So, dito natin malalaman na yung weight ng ating, yung displaced water is 3 pound of water. Okay, 7 minus 4 man. So, meron tayong nawawalang 3 pound of 3 pound na weight. So, another presentation lang or representation para dun sa ating Archimedes Principle. So, sample nito is itong rock. Giveaway natin siya. So, sa scale, meron siyang lumabas na 29.4 Newton. So, ito siya yung ating weight ng ating rock. So, again, yung ating weight is equal siya doon sa ating, wait lang. Tama. Kung ang lumabas sa scale is 29.4, syempre, yun yung ating weight. Diba? Next, nung once nag-submerge na yung ating rock, yung kanyang weight na from 29.4 Newton is naging 19.6 Newton. So, with the representation ng ating free body diagram, di ba yung weight natin, di naman mag-change siya, 29.4. So, meron tayong 29.4. No, nandito na ha. Dito na siya na part. Dito na siya na illustration. So, yung weight natin, 29.4, downward direction. Yung scale natin is 9.6 ang lumabas. So, upward siya. Itong scale din natin ito, okay, 19.6. So, nasaan yung nawawalang weight? So, yun siya yun na yung ating buoyant force, which is 9.8 Newton. Buoyancy is a force. It is measure of the upward force of fluid exerts on an object that is submerged. Okay, so yung weight is equals siya kung nasa nakasubmerged na, weight of the object is equals to the buoyant force. The water in the pool, with regards to illustration na ito, the water in the pool exerts an upward force that acts in a direction opposite to the weight, to the buoy's weight. Next, yung ating weight. Weight is also a force like any other pushing or pulling force. It is caused by the Earth's gravity. It is easy to confuse mass and weight, pero tackle lang natin to last meeting, but they are not the same. Weight is a downward force of the gravity acting on the mass. Next is yung density and buoyancy. When they are completely underwater, both balls, dito with regards sa ating figure, have the same buoyant force because they displace the same volume of water. Example is itong ating steel ball and then yung ating wooden ball. However, yung ating steel ball, syempre, steel, mas mabigat siya kaysa doon sa ating wooden ball. So, it has, yung ating steel ball, it has higher density. Volume and buoyancy. The strength of buoyant force on an object in water depends on the volume of the object that is underwater. So we have here an illustration. So kung pabayaan lang nato ang atong ball, magfo-float lang siya. Siyempre may hangin yan sa loob eh. So yung weight is equal siya dun sa ating buoyant force. Pero once na mag-exert tayo ng additional force doon sa ating bola para lang masubmerge pa siya lalo, mayroon tayong mafe-feel na parang nag-against na pwersa. So yung pwersa na yun siya yung ating buoyancy or yung buoyant force natin. Again, as you keep pushing downward on the ball, the buoyant force also gets stronger and stronger. So, i-equate niya lang, parang papantayan lang ng buoyant force yung pwersa pa na gi-add mo para lang masubmerge itong ball pa. And again, apparent density. An object with an object with an apparent density greater than the density of water will sink. Pero yung object with less apparent density, then yung ating object will float. Sample dito, steel ball nga, pero yung isa solid and then yung isa hollow. Siyempre, obvious naman na yung mag-float is yung hollow steel ball. So again, yung ating mga forces acting with regards sa ating buoyancy na topic. So meron tayong gravity, which is yung weight natin, and then yung mass ng ating object. So yung ating weight makukuha with the solution na mass times gravity. And then meron tayong buoyancy force, which will be topic will be discussed later on. Again, yung ating Archimedes Principle, the buoyant force on an object is equal to the weight of the fluid displaced by the object. So yung ating buoyant force is equals to the weight, which is equals naman siya sa mass times gravity. And then yung ating dapat density ito, hindi siya unit weight. So density equals to mass over volume. So yung mass natin is equals to density times volume. So yung buoyant force natin is equals to the unit weight or density times dun sa volume na nakasubmerge. It is not the object that exerts the buoyant force. It is the fluid that the object displaces that causes it. That causes it. So, yung ating formula para sa buoyant force is equals to the unit weight ng ating fluid times dun sa gravity times dun sa volume submerged. So, meron tayo ditong sample problem ha. So, an iceberg having a specific gravity na 0.92 is floating on the salt water with a specific gravity na 1.03. If the volume of ice above the water surface is 1,000 cubic meter, which is itong exposed lang ha, exposed sa hangin. Yung submerged natin na volume displaced is unknown. What is the total volume of the ice? Okay. So yung magre-represent tayo dito. So yung V, total volume of ice. Yung VD is yung volume displaced. So yung ating VE, which is 1,000. So ano lang natin, equate natin. So yung ating volume displaced is equals to the total volume minus dun sa 1,000, which is yung ating volume exposed. Okay. So next is yung ating weight. Kukunin natin yung ating value para sa weight. So weight natin is equals to unit weight ng ice times nung sa total volume ng ating iceberg. Okay? So meron tayong equation na 9.81 times 0.92, which is specific gravity ng ating ice. Okay ha? Huwag kalimutan ng specific gravity. Times the total volume. Yung total volume natin is unknown pa. So gagawin lang natin siyang variable. So we have a volume of ice na 9.0252 times sa total volume. Next, kunin natin ang formula, ang value para sa buoyant force. So yung ating unit weight of seawater times doon sa volume na naka-displace or naka-submerge. So, yung unit weight of seawater, again, 9.81 times the specific gravity ng seawater, which is 1.03. Okay? So, 9.81 times 1.03 ito. And then yung VD natin, it's ito na. V minus 1,000. So, ipang-substitute lang natin. So, yung volume, buoyant force natin is equals to 10.1043 open parenthesis, volume, total volume minus 1,000. So, equate natin siya with the summation of vertical forces. So, weight is equals to BF. So, meron tayong 9.0252 V is equals to 10.1043 V minus 1,000. So, since isa lang yung unknown natin, pwede natin siya input na sa calculator, shift so, meron tayong total volume na 9,364 cubic meter. Okay, so yan yung answer natin para sa ating problem. So may another solution dito, hindi ko na i-discuss class ha, para may oras pa para doon sa video presentation natin para further illustration na din sa inyo at further ma-internalize ninyo yung ating topic. So before tayo dun sa video presentation, dun na muna tayo sa assignment ninyo. So assignment number 3, problem number 1, a 70 kilogram statue lies at the bottom of the sea. Its volume is 3.0 times 10 to the negative 2 cubic meter. How much force is needed to lift it? Ano ba yan? Oy, Sorry. Number 2, a rectangular block of wood with the dimension na 1.0 meter by 2.0 meter times 0.25 meter floats so that 0.15 cm of its height is above the water level. So hanapin natin ang kanyang density. So density of wood and then mass of the wood. So doon nagtatapos. So dito nagtatapos yung ating slides para sa buoyancy. Pero before tayo mag-end ng ating video, recorded lecture, play muna natin yung ating video presentation para sa buoyancy. Sandali lamang. So here, we have the video presentation para sa buoyancy. So ipi-play na natin.
In this video, we're going to talk about Archimedes Principle and buoyant force. The basic idea of Archimedes Principle.
Wait lang. Yapit dito.
In this video, we're going to talk about Archimedes Principle and buoyant force. The basic idea behind Archimedes Principle is that the buoyant force acting on an object that's immersed in a fluid is equal to the weight of the fluid displaced by that object. Now, this problem is going to illustrate the concept of Archimedes Principle, and you'll see it as we go through the problem. But now, let's talk about something. Let's say if you want to lift a block with a rope in air. Is it easier to lift it up in air, or is it easier to lift up the block if it's submerged in water? What would you say? It turns out that it's a lot easier to lift up the block when it's submerged in water, since water has a higher density than air. The portion of water that's displaced by the block exerts an upward buoyant force on the block, which we'll call FB. And as a result, the tension in the rope doesn't have to be as great. So objects appear to be lighter in water than in air. And this is all related to Archimedes' principle. So let's focus on this example. So we have a 10-kilogram block of aluminum attached to a rope. What is the tension force in a rope if the block is in a vacuum? So let's say that is the aluminum block, and we have an upward tension force that's lifting up the block, and then there's the downward weight force acting on the block. Now, in a vacuum, there is no upward buoyant force because there's no air molecules to lift up the weight of the block. So therefore, the tension force would represent the true weight of the block. And the weight of the block is mg. So the tension force is equal to mg. So the mass is 10 kilograms and g is 9.8. So the answer for part A is 98 newtons. That's the actual weight of the block. Now what about part B? What is the tension force if the block is in air? Now air is a fluid the same way as water is a fluid. So as a result, air is going to push up the block with an upward buoyant force. So the sum of all forces in a y direction is going to be based on the two upward forces. That's going to be positive T and positive FB. And the weight force is in a negative y direction. So we're going to put negative W. In order to get the minimum force that the rope has to apply in order to keep the block stationary, if we don't want the block to fall or to accelerate upward, if we want it to stay in place, the net force in the y direction must be 0. So solving for the tension force, we need to take these two terms, move it to the other side. So W is negative on the right side, but it's going to be positive on the left. And the buoyant force is going to be negative on the left. So the tension force is the weight force minus the buoyant force. In part A, there was no buoyant force, so the tension force was just the weight force. But for parts B and C, the tension force is going to be the difference between the weight force and the buoyant force. Now, how do we calculate the buoyant force? What can we do to find the answer? Now, let's say if we have an object submerged in a fluid. The fluid could be water or it could be air. And let's use a cylinder. The fluid exerts a force on the top surface of the cylinder, which we'll call F1, and it also exerts a force on the bottom surface, F2. The difference in these two forces is equal to the buoyant force. As you go deeper in water, the pressure is greater. So because the pressure at the bottom is greater than the pressure at the top,
Pantene. Enriched with pro-vitamins, iwas bigtas, ano man ang style.
F2 is going to be greater than F1. The deeper you go in water, the greater the force that it will exert on you. And so that's why we have a net upward buoyant force, because the pressure is greater at the bottom than it is at the top. So that buoyant force is the difference between F2 and F1. Now granted, the fluid does exert a force in the x direction, but these forces cancel out because they're at the same depth. So we don't have to worry about that. So only the forces in the y direction is what we're concerned about. Now force, well, we know that pressure is force divided by area. So force is pressure times area. So F2 is going to be P2 times A, and F1 is P1 times A. Now A is the same. The area of the top part of the cylinder is the same as the area of the bottom part of the cylinder. We're assuming that we have a uniformly shaped cylinder. So now what should we replace P2 and P1 with? Now the pressure exerted by a fluid is force divided by area, the force that the fluid exerts over a given area. And the force exerted by the fluid is basically the weight of the fluid. And density is mass over volume. So mass is density times volume. So we can replace M with rho times V. And volume is basically area times height. So we could cancel A. So the pressure exerted by a fluid is equal to the density times the gravitational acceleration times the height. So we can replace P with that, rho GH. Now this is going to be the density of the fluid times the gravitational acceleration times the height. Now the height is going to be different at these 2 points. So H1 is the distance between the top surface of the fluid and where the force acts. H2 is the difference between the surface of the fluid and this location, the bottom part of the cylinder. So P1 is going to be the density of the fluid times G times H1 times A. Now let's factor out PF, G, and A. So the buoyant force is equal to rho GA times H2 minus H1. Now if we take the difference between H2 and H1, this will give us the height of the cylinder, which I'm going to call just H. And now let's get rid of some stuff. So the buoyant force is equal to the density of the fluid times the gravitational acceleration times the area. And then let's replace H2 minus H1 with H. Now, A times H, that's the volume. So here's the equation for the buoyant force. It's equal to the density of the fluid times the volume times the gravitational acceleration. You may want to write down this equation. Now, the density of the fluid times the volume of the object submerged. In this case, the entire object is submerged. That will give you the mass of the fluid. As we said, density is mass over volume. So density times volume is mass. So m is equal to rho times v. So the buoyant force is equal to the mass of the fluid times the gravitational acceleration. And mg is basically the weight. So the upward buoyant force is equal to the weight of the fluid that's displaced by the object. And so this is the basis of Archimedes' principle, which states that the buoyant force of an object immersed in a fluid is equal to the weight of the fluid that's displaced by the object. So that expression is the basis for Archimedes' principle, and this is how we can calculate the upward buoyant force. So based on the picture that we drew, we had an upward tension force, a downward weight force, and an upward buoyant force. And we said that the tension is the difference between the weight force and the buoyant force. So now to answer part B, we need to calculate the buoyant force. In order to do so, we need the volume of the aluminum block. So density is mass divided by volume. If you rearrange the equation, let's cross multiply. So m is equal to rho v, and solving for v, we need to divide by the density. So the volume of the aluminum block is going to be the mass of the block divided by the density of the block. The mass of the block is 10 kilograms, and the density is 2,700 kilograms per cubic meter. So let's divide those two numbers. So the volume of the block is 0.0037 cubic meters. So now we can calculate the buoyant force acting on the block in air. So the density of the fluid in part B, which is air, is very small, it's 1.29, and the volume is 0.0037 times the gravitational acceleration of 9.8. And so the buoyant force is 0.047 newtons. So the tension of the rope in air is going to be the weight force, which is 98, minus the buoyant force of 0.047, which is really not going to make much of a difference. So the tension force is slightly less. It's 97.953 newtons. So if you wish to calculate the weight of an object in air, it's going to be almost equal to the true weight, in this case, which is 98 newtons. But now let's see how much is going to change in water. So the volume of the object is going to be the same. However, the buoyant force is different because the density of the fluid is different. So the buoyant force caused by the displaced water molecules is going to be the density of the fluid, which the density of water is 1,000 kilograms per cubic meter, times the volume of the submerged object, which is 0.0037 times g. So the buoyant force is 36.26 newtons, and that's significant. So the tension is going to be the weight force, which is mg, that's 10 times 9.8 or 98, minus the buoyant force of 36.26. And so that's going to be 61.74 newtons. So as you can see, it's a lot easier to lift up the block in water than it is in a vacuum or in air. In air, it's almost about 98 newtons of force that's required to lift up this block. In water, it's only 61.74 newtons. So as the density of the fluid increases, it becomes easier to lift up the block that is submerged in that fluid.
Kitang taga Mindanao, abtik mo trabaho basta para sa pamilya. Sa lain-laing sakit sa abtik banat nga Rexidol Forte na. Abtik yun ang Rexidol Forte. Kontra sa bughat, pamaon, labad sa ulo o hilana. Ang madiskarte nga taga Mindanao, muasensog yun. Rexidol Forte, abtik banat sa upat.
Unilab yan.
Let's talk about fluids. Fluids are, of course, everywhere, right? Water is all over the earth. Water is inside of us. There is fluid in this pen.
Buoyant force.
Okay, dito nagtatapos yung ating video
And that's
presentation. Okay,
So the
thank you
tension is gonna be the
everyone.
weight force,
See you
which
next
is mg,
next
that's
video.
10 times 9.8 or 98 minus the buoyant force of 36.20.